In this question, we're going to count the number of ways that a ballot can be created. Now, this ballot has to have the names of 4 Democratic candidates and 5 Republican candidates. The Democrats are all going to be together in one section, and the Republicans are going to be together in another. And we want to know how many different ballots are going to have to be printed out if all of the possible combinations need to be made available. Now, to do this, I think it helps to kind of start by taking a look at some sample ballots, okay, just so we kind of see what we're talking about here. In this first ballot, we have a block of Democrats, and a block of Republicans. Then in this second sample, we've got the same thing. We've got a block of Democrats and a block of Republicans, but the order of their names has been changed around. And then we also have to consider this case where the Republicans come first and the Democrats come second. Okay? Now, here's how this entire process is going to go. All right? First, we're going to calculate the number of ways to arrange the Democrats within their block. All right? Then we're going to calculate the number of ways to arrange the Republicans within their block. Now, step 3, we're going to use the multiplication rule to calculate the number of ballots with the Democrats and then the Republicans. Then we're going to use it again to calculate the number of ballots with Republicans and then the Democrats. And finally, we're going to use the addition rule to bring both groups together. Now, let me be clear on what we're doing on all of this process here. We're going to start with counting the number of ways to arrange the Democrats. Then we're going to count the number of ways to arrange the Republicans. Now, to create a ballot, we have 2 choices we have to make. We have to choose one group from the list of Democrats, and we have to choose another choice, another set from the list of Republicans. So because we're making 2 choices here, we're going to use the multiplication rule to find the total number of ballots we can make that way. Then we're going to do the same thing again, but this time we're going to start with the Republicans. We're going to make that choice first. Then we're going to choose the Democrats. And again, we're making 2 choices here. So to find the total number of choices, we're going to use the multiplication rule. All right, so now at this point, we have 2 sets of ballots. We have one set that has Democrats and then Republicans. And we have another set that has Republicans and then Democrats. 2 different sets. To get a final ballot, we need to pick one of these. So we're making one choice from 2 sets of ballots that have nothing in common, right? So this is a situation where the addition rule applies. Okay, so let's start walking through this process with some numbers here. First, we're going to count the number of ways the Democrats can be arranged within their section, right? We have 4 Democratic candidates, and they're all going to go on the ballot. So we have to arrange them in a group of 4. Now, the order they're placed on the ballot matters, all right? In terms of statistics and politics, the order matters. Being placed first is considered preferable. So the sequencing is important, which makes this an example of a permutation. So we're going to use the permutation formula here, right? It's going to be 4P4 that we're looking for. So if we substitute those numbers into the formula, we get this. And if we start simplifying, 4 minus 4 is 0. 0 factorial is 1, which makes this equal to just 4 factorial. And 4 factorial is 24. Now, hold on to that number, okay? Hold on to that number. And we're going to go to step 2, where we calculate the number of ways to arrange the Republicans. And this is going to be very similar, right? Now we have 5 candidates. We have to arrange all 5 of them on the ballot. Again, this is going to be a permutation because the order matters. So we're going to substitute 5 for N and 5 for R in the permutation formula. And that's going to give us this expression, which simplifies to 5 over 0 factorial, which is, 5 factorial over 0 factorial, which simplifies to 5 factorial over 1, or 120. Now, once again, hold on to that number. Okay, now we're going to go to step 3, where we count the number of Democrat first ballots, right? That was the ones that have a Democrat in the top section and a Republican in the bottom section, right? So to do this, we need to make 2 choices, right? So we're going to apply the multiplication rule, and that's going to give us 24 times 120, or 2,880 Democrat first ballots. Now, step 4 is very similar, right? As a matter of fact, when you see when we get to the numbers, it really is identical. Now we need the number of Republican first ballots. So that's going to be the number of Republican ballots times the number of Democrat ballots. And once again, now instead of 24 times 120, it's 120 times 24, and we end up with the same number, 2,880. All right? Now we're coming up on the end here. All right? We have 2 sets of ballots. We have one set that has Democrats and then Republicans, and we have another set that has Republicans and then Democrats. These two groups have nothing in common, right? So the total number of ballots, we're going to apply the addition rule. It's going to be the sum of their counts, 2,880 plus 2,880, which gives us a total of 5,760 ballots.